Greetings, ladies and gentlemen. Today we're going to be talking about permutations. Permutation is an arrangement of things in which order is important. If order matters, you're going to use a permutation. Tomorrow, and I mean by tomorrow, Monday night, when you watch your Monday night video, you're going to learn about something called a combination, and their order does not matter. So this idea of I care about the order in which I select the objects in the problem, that is a permutation. Typically, we look for jobs. If you have a job to do, you are a permutation. Okay. Now here we have class officers. So you're talking about president, vice president, treasurer. Those are jobs. The first person in the batting lineup and the second person, the order matters in order to put together a effective offense. Okay. Getting in a line. A line is a permutation because being first in the line and being second in the line is different, and it matters in which spot you are in. So permutations, order matters. How many ways can 3 students be called upon to present a problem to the class? Student A, B, or C? Well, there are 3 ways to select the first student. So say it's student C, just to pick somebody. Then there are 2 students left to answer the second question. And there are 3 students left to answer the remaining question. And the counting principle tells us we're supposed to be multiplying the number of outcomes for each situation here. So 3 times 2 times 1 is equal to 6. So there are 6 ways that 3 students can be called upon to present a problem to the class. They are ABC, ACB, BAC, BCA, CAB, and CBA. Those are the 6 possible orders, but of course we don't need to write those orders out to do the problem. That's just to illustrate the point. Alright, so there is something called factorial. You can see it spelled here. That exclamation point symbol means start at the number that's in front of the exclamation point and then keep decreasing by 1, multiplying as you go until you get down to 1. You can see that swallowing my tongue here. Start at n, decrease by 1, decrease by 1, decrease by 1. Keep doing it until you get down to 1. Multiply all those things together. 6 factorial, 6 times 5 times 4. And you keep subtracting 1 from the previous number until you get down to 1. Well, 6 times 5 is 30, times 4 is 120, times 6 is 720. There is a factorial key on your calculator, and we will take a look at it tomorrow in class, or I should say Monday in class together. 1 factorial would just be 1. Since it starts at 1, there's really nothing to count down to. Factorial is a big part of probability. How many words can be made from Q, W, E, R if the letters are used once? If you're going to use every single letter, there are 4 letters, you can just write this as 4 factorial. 4 ways to choose the first letter, 3 ways to choose the second letter, 2 ways to use the third letter, and then the 1 letter that remains. 24 is the answer. You have to use every single letter in order for you to go with the factorial. You got to use them up. If you're not using them up, we do something called a permutation. Alright, we're going to talk about that too. But before we get to that, how many ways can 5 people line up? Since all 5 of them are lining up, we can use factorial to demonstrate how to do that. 5 times 4 is 20, 3 times 2 is 6, 6 times 20 is 120. 5 factorial. So, basically what we have here is factorial notation starts at the number, works all the way down to 1. If order matters and you're going to use every single element, use factorial if order matters and you're going to use all the elements. Then you're going to use factorial. Alright, permutations are for when we are not going to use all the elements. This symbol here, P, stands for permutation. We are going to use that symbol if we do not want to use every single element up. If I was going to put all 6 students in a line here, that would be 6 factorial, which we saw earlier is 720. I can't use that though, because I don't want 6 students to go up to the board. I want 3 students. So NPR, n things taken r at a time. We read this as 6 pick 3. And the way you do a permutation is start at the number on the left, and we want 3 digits. 6 is 1 digit, 5 is 1 digit, 4 is 1 digit, then we multiply them together. So you're counting down like a factorial, but you're only going to do it 1, 2, 3 times. Okay, you're not going to go all the way down to 1. So 6 times 5 is 30, times 4 is 120. 9 basketball players. You want 4 of them to sit on the bench. So of the 9 players, you are going to pick 4 of them to sit on the bench. Start at 9, and we need 4 digits. Okay, 9, 8, 7, 6. Now that number is a little bit bigger. What a great opportunity to pull up our graphing calculator, and I'll show you where this is located. We want to do 9 pick 6 on the calculator, which is 9 times 8. I'm sorry, 9 pick 4. 9 pick 4, which is 9 times 8 times 7 times 6. So we go to get rid of some of this so it's not so big. Here's what we're going to do. Put a 9 on there. Hit the math button. And we're going to go over, see this PRB on top? That is probability. You'll notice choice 2 is NPR. Choice 4 is the exclamation point. So there's your factorial. It's on the PRB tab when you hit the math button. So there's 9 NPR 4. And that is going to compute the answer for us. That is the same thing as 9 times 8 times 7 times 6. Starting at 9 and go down until we have 4 numbers. 3024 is the answer. Whoa, get up there, answer. Where are you going, answer? Gotcha. All right. There are 12 horses in a race. How many ways can they place? Well, placing, there are 3 places. So we go 12 pick 3, 12 times 11 times 10. And once again, just to review, hit the first number 12. Hit the math button. Go over to PRB and down to NPR, which is choice 2 in the list. 12 pick 3 gives you 1,320. Or just do 12 times 11 times 10. How many 3-letter words from logic? Now, we had QWER on the last screen. We used all 4 of the letters, so we just did 4 factorial. Here, we're not using up every single letter. There are 5 letters. We're only going to pick 3 of them. So that's 5 times 4 times 3, which is 60. Ooh, lottery ticket. A lottery ticket has 4 digits. How many winning combos if digits are used once? Well, what are the digits? 0 through 9. That means there are a total of 10 digits. Okay. So how many winning combos if the digits are only used once? We do 10, pick 4, which is 10 times 9 times 8 times 7. So those numbers are a little bit bigger. 10 times 9 times 8 times 7 gives us 5040. 5,040. Remember, you can do that by hitting 10, math, going over to the PRB tab, and selecting choice 2 there, and putting in a 4, NP4. Okay, so either way, just multiply the numbers out if the list isn't too big, or you can get into that math menu. How about if the digits can repeat? If the digits can repeat, this is not a permutation. There is a difference from A and B here. If the digits can repeat, there are 10 digits for the first choice, 10 digits for the second, 10 digits for the third, and 10 digits for the fourth. There is no formula for doing that. You just figure out the total outcomes for each event and you multiply them together. B is a replacement problem, which we dealt with over the last couple of days. All right. Replacement is not an NPR, so don't use a permutation when things are being replaced. All right, let's compute 7 factorial over 3 factorial. Very interesting thing happens here when you divide factorials like this. This is 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, 3 times 2 times 1. Cancel some stuff out before you multiply. Then we get 7 times 6, 7 times 6 times 5 times 4, which is 840. Okay? 840. So just expand the top, expand the bottom. Now, can I do that on the calculator? Ooh, I don't know. 7 math. Go over to the PRB tab. And choice 4 is factorial. So there's 7 factorial divided by 3 math. Go over to that PRB tab. 3 factorial. Hit enter, and there's your 840. Okay, so that works as well. Remember, if you have more than one factorial in the denominator, you need to put parentheses around the denominator. Okay? All right, so that's that page. Permutations with repetition. Now, this gets a little bit weird. Basically, they're going to have items in the list where you have repeated letters. So when there are repeated letters, there is really no difference by eek spelled like this, or if I replace the third E with the first E, it would look like that. I mean, it's the same word, except I've switched a couple of E's around. You're not supposed to count that as a separate word. Okay? So when that is done, you take the total factorial divided by the number of repeats factorial. So we're talking about 4 letters. We're using them all up, okay? So it's 4 factorial. That looks like 41, so let me try to be a little bit neater. 4 factorial, and then there are 3 E's. So we do 4 times 3 times 2 times 1 over 3 times 2 times 1. Problem is easy to the point where I'm not going to bother wasting time typing it in the calculator. The total number of letters factorial, or in the case here, digits, divided by the number of repeats. So we have 1, 2, 3, 4, 5, 6 digits, and 4 2's. So 2's being repeated 4 times. So 6 times 5 times 4, etc. On the bottom, 4 factorial. Cancel, and you get 30. Number 3. Rita and Marie wash dishes each night of the week. 3 nights for Rita, 2 nights each for Anne and Maria. How many different schedules are possible? So think about what we've got here. We've got Rita, Rita, and Rita. We have Anne and Anne. We have Maria, Maria. So we count that up, 1, 2, 3, 4, 5, 6, 7. That's 7 factorial divided by 3 for Rita, 2 for Anne, 2 for Maria. Okay, this can get nasty, so let's just put it in the calculator. Clear this one out. 7, math, go over to PRB, hit 4 or arrow down to factorial, divided by, now I'm going to do parentheses because I have multiple things on the bottom, 3, math, PRB, factorial, times 2, math, PRB, factorial, times 2, math, PRB, factorial. Close the parenthesis up, and you get the answer 210. Well, where does 210 come from? Here's where it is. 7 times 6 times 5 times 4 times 3 times 2 times 1 on top. On the bottom, 3 times 2 times 1 times 2 times 1 times 2 times 1. These cancel out. Boom, boom, boom. 2 goes into 4, remainder 2. Or 2 goes into 4 twice, I mean. Here the 2's cancel out, so 7 times 6 times 5 is the only thing left over, and that is 210. It's important that you're aware 3 factorial, 2 factorial times 2 factorial is absolutely not equal to 12 factorial. 12 factorial is gigantic. The denominator of this particular fraction is only 6 times 2 times 2. It's only 24. It's tiny. Well, 12 factorial is way bigger than 24. They are not the same. Not equal. Not equal. Okay? How many words from system that start with the letter T? All right. This is a bit of a trick question. You might say, well, listen, 1, 2, 3, 4, 5, there's 6 letters, and there are 2 S's, so I'm going to do that. But that is absolutely not right, because the first letter is starting with a T. So the first spot of my new word has to have a T in it. So take the T out and pretend it's not even there. There is actually 5 letters and 2 S's. So we do 5 times 4 times 3 times 2 times 1 over 2 times 1. So we're talking 60. Just deal with the T, take it out because we know where it's going. There is no outcome that doesn't have it in there. So there's no reason to be like playing around like it's going to be in those 6 letters. It's simply not going to be there because it's your first letter. So put the restriction down and then do the factorial for the rest of the problem. As you can see, we're going to be on page 634 and 638. I look forward to seeing you on Monday. Have a wonderful weekend.